Continuing 7.1, An Introduction to Landslides. The next force on slope we will discuss is slope and topography. I think these are pretty intuitive. First, topographic relief. Mass wasting occurs more in high relief areas. Second, the slope. Steeper the slope, the greater the driving force. Very steep slopes are associated with rock falls, avalanches, soil slips, if there is any soil in the first place. Moderate slopes are associated with earth flows, and gentle slopes are associated with creep. Next force on slope that we will consider is climate, mostly meaning how much and what type of water an area gets, but temperature also plays a minor role. Things to consider for water include amount and timing of water that infiltrates or erodes slope. Is there a lot of water erosion? Does the water soak in or just flow off the slope? This leads to type and abundance of hillside vegetation. In arid areas, there is limited soil development and vegetation, making the area more prone to rock falls, debris flows, and soil slips. In subhumid to humid regions, the soil is much thicker and supports lots of vegetation. These areas are prone to complex landslides, earth flows, and creep. The image on the top is of an arid area, and the image on the bottom is of a more humid area. You can definitely see cliffs in the top image, but not cliffs in the bottom image, even though the area is quite steep. You need cliffs for rock falls. Vegetation as a force on a slope is not clear-cut. It is a function of climate, soil type, topography, and fire history. Vegetation provides protective cover that slows surface erosion and provides conduits for water infiltration. Roots can add strength and cohesion to slope materials. However, vegetation adds weight to slopes as well. Let's look at the images. Top right cartoon shows deep tree roots growing through the less consolidated soil and into the more consolidated rock below. These deep roots anchor the loose soil to the hillside. The bottom right image is of soil after a fire. There is not much vegetation growing at the moment, and you can see some mass movement here, where there is a slightly browner sediment that has fallen along the slope onto the path. See it? Finally, the bottom left image shows plants that are not helping the slope stay intact. These ice plants have fairly shallow roots and may have even required irrigation. They added enough weight to cause mass movement on this slope. Another important force on slopes is water. Primarily, it increases soil weight, but can also increase pore pressure, making material more prone to flow. During rainstorms, water saturates soil, causing landslides, i.e. shallow soil slips and debris flows. After rainstorms, water continues to saturate the soil, causing landslides, e.g. slumps. Flowing water can also erode the base of slopes to decrease stability. We know all about that so important toe. Water can cause spontaneous liquefaction of some clay and other fine-grained sediments, which provides a wonderful zone of weakness for a slip lane. The cartoon asks, what triggers off landslides? And shows a poor home at the base of a slope and it's raining, and the rain is percolating down into the soil and says, slope becomes unstable because of the wet soil. Water is a force on slopes that changes rapidly, so it is often pointed at as a major cause of why this landslide now. What changed? The amount of water in the soil. Time is another force on slopes. It was just a matter of time. Forces change with time. Driving and resisting forces change with season due to changes in moisture content and water table height. Chemical erosion also occurs slowly over time. Carbon dioxide and water combine to form weak carbonic acid, which slowly dissolves rocks, especially limestone. The image shows highly eroded karst topography in China. All the rock that used to be between the cute tree-covered mounds has been slowly dissolved and washed away by carbonic acid. These remaining steep hills are prone to the landslide hazard. So for a quick summary again, the forces on slopes that we discussed are earth material type, slope and topography, climate, vegetation, water, and time. Hopefully you can now tell me or someone else what these things have to do with slope stability. On to a brief bit about snow avalanches, partly because they are so deadly. They are the rapid downslope movement of snow and ice and may contain rock and vegetation as well. Avalanches are affected by steepness of slope, which concerns the angle of repose. This describes steepest stable slope, and that depends on factors such as temperature, wetness, and shape of snow grains. Typically, snow slopes greater than 25 degrees are unstable. But note that slopes greater than 50 to 60 degrees are too steep for snow to build up, so do not pose much of an avalanche risk. Avalanches move down chutes, and avoiding these areas can minimize the hazard, i.e., don't picnic in a chute. Top right picture is a beautiful avalanche coming down a chute. It is beautiful because I am not in it. The other image, the cartoon, shows how grain size affects the angle of repose. Fine sand has a lower angle of repose than angular pebbles. There are two main types of snow avalanches. Loose snow avalanches, which widen as they move downslope, and slab avalanches, which move as a cohesive block. These are more dangerous and damaging and are triggered by overloading slope or zones of weakness in the snowpack. The top image is of a loose snow avalanche, and the bottom image is of icy snow looking like it's getting ready for a small slab avalanche. Either snow avalanche type can kill, and does, each season. 7.2. Geographic regions at risk from landslides. It shouldn't surprise you that anywhere that has significant slopes and mountains is at risk. Most places have some local significant slopes, even if in general the area is fairly flat, which means most areas are at risk. Factors expected to increase landslide activity include urbanization and development of landslide-prone areas. Of course. Tree cutting in a landslide-prone area, and changing global climate patterns, i.e. change in precipitation distribution. By the way, there's your answer to my opening question. Next question is the Boise-Nampa area at risk from the landslide hazard. What areas are probably at the highest risk? Think of the slopiest areas. When during the year is the risk the highest? Here's a hint. When do we get the most precipitation? Is there a history of landslides in the Boise-Nampa area? If you don't know, what's your guess? Google it and find out if you're right. 7.3. Effects of landslides and linkages with other natural hazards. Landslides can do significant damage. In the United States, about 25 people are killed each year, with damages exceeding $1 billion. People are hurt and killed when hit with or buried in falling debris. Slides may damage homes, roads, and utilities, blocking roads, which impedes travel, or blocking streams, which causes flooding. In addition, as the land is stirred up, you can breathe in spores that can cause disease. Ever hear of valley fever? Here's a quote from WebMD about it. You can get valley fever if you breathe in the fungus that causes the disease. The fungus grows in the soil. It gets into the air when the ground is broken, and the dirt and dust spread into the air. Landslides are linked to almost all other hazards. Earthquakes, volcanoes, storms, and fires may cause landslides, while landslides may cause flooding or tsunamis. Get creative. Can you think of more links between landslides and other natural hazards? Remember to explain your ideas. For instance, earthquakes can cause landslides because they shake earth material, which could cause loose material to move downslope. Another example, landslides can cause flooding because a landslide can block a stream and form a temporary dam, causing water to back up upstream. And when the temporary dam fails, the backed up water will also flood downstream. I can go on, and I'm sure you can too. If you are not sure, you have good reasons. Ask me via email. 7.4 Natural service functions of landslides. So why might we want landslides to occur? Well, they can produce deposits that become mineral resources, such as gold or diamonds. And they can create new habitats in forests and aquatic ecosystems, which increases plant and animal diversity. To illustrate the last point, imagine a dense forest on a mountainside, and then a clearing formed through it by a landslide, finally providing a place for wildflowers and butterflies to thrive. Result? Increased diversity. Back to gold. The image below is of a gold placer deposit. Mass movement brought the gold down the mountain in a jumble of debris. The debris was further sorted by streams and then deposited in the bedload of a stream. FYI, in the image, the stream was flowing into or out of the pitcher. The deposit formed a nice gold smile. I also have a diamond story. So, there are diamonds in some of the sediments of the Amazon rainforest. Some of these diamonds are actually sourced from kimberlite dikes in Africa. We know because diamonds have unique chemical signatures that match their source. Well, the story goes like this. Way, way back in the day, when Pangaea was still around, mass movement was still happening, eroding the kimberlite dikes, carrying sediment downslope. Part of the downslope movement was to the west. Streams assisted with the sediment transport as they are the primary cause of erosion on Earth's surface, but they transported what mass movement started. Plate tectonics also moved the diamonds away from their source as the mid-Atlantic ridge broke apart Pangaea, forming the Atlantic Ocean. And now we have, thanks to mass movement, African diamonds in the Amazon. Neat story, huh? 7.5 Human interaction with landslides. Urbanization increases landslide activity through removal of anchoring vegetation, construction of roads, building at higher elevations, improper grading of benches cut into slopes for home sites. Migrating will not cause landslides. And placing fill materials on slopes. Think of the slope diagram and the discussion. Does this make sense? Removing anchoring vegetation decreases the friction on the potential slip plane. Road construction is often at the base of a slope, and the toe of the slope is critical in keeping the rest of the slope in place. Remember? Mass and slip plane ratios, and more.